This is lesson number 2. In lesson number 2, we'll look at multiplication and also introduce the concept of division. As usual, I like to ask the question, what is? What is multiplication? Now, hopefully, you know how to multiply. That's the assumption I'm making here, that people who are watching this tape, whether you are an elementary school age student or an adult or something in between, you know how to multiply. But what is multiplication? And hopefully, in your mind, what multiplication is repeated addition. In fact, I am told, I was not there, that in ancient Egypt, before multiplication was discovered, that every time a problem that we would do by multiplication had to be done by addition, they'd write the answer down and put it on a brick or on a scroll and keep it in a library because it was so much work to do these problems. And in fact, then someone created multiplication. Multiplication is repeated addition. For example, in our first visual, we see that 6 times 8 means 8 plus 8 plus 8 plus 8 plus 8 plus 8. 6 eighths added. And of course, the answer is 48. Once you learn to multiply, you basically forget this and just simply remember your facts. But it's always a good idea to go back to understand what multiplication is. As again, we get to fractions, decimals, even into algebra, understanding what multiplication is can be very helpful. Notice, multiplication is not counting. It's one step above. Addition and subtraction were counting. Multiplication is now something different. It's repeated addition. It is not counting. The rules are different. Another way to conceive of multiplication is by looking at, for example, the next visual, which shows you a physical representation of numbers that multiply to be 12. Here we have 3 rows of 4. That is, 3 times 4 is 12. Notice if you turn your head sideways, you might see 4 rows of 3. 4 times 3 is the same as 3 times 4. That's 12. The next visual gives an alternate approach to multiplication of two numbers, giving an answer of 12. 2 rows of 6, or if you like, 6 columns of 2. So that 2 times 6, or 6 times 2, is 12. And the next visual gives a third way to multiply two numbers to get 12. 1 times 12, or 12 times 1. Now, let's take a look at a somewhat special number. The number is 9. In our first visual, we see that we have 1 times 9. 1 row of 9. We also could look at it as 3 rows of 3. This is very special. Every one of the arrangements so far has been rectangular. That is, with 12, 3 rows of 4, 2 rows of 6. But this is more than a rectangle. This is a square, 3 rows of 3. And in fact, if you turn it sideways, you still have 3 rows of 3. And in fact, 9 is called a square number because one of the ways to multiply it looks like a square. This will become even more important in future lessons. But right now, let's just recognize that these rectangular arrays, these rectangular groupings of physical things, show us what multiplication truly means. Now, a question I always like to ask involves the next visual. We're multiplying 38 times 247. Now, at this point in time, I'm not going to ask you to multiply. I'm just going to say, look at the 2 and the 3. They are connected. Where, let's see, 2 times 3 is 6. Where does that 6 go? In what place value? So stop the tape and decide where the 6 goes and justify your answer. Well, a lot of people would try to do that by actually multiplying the entire problem. No. We have 2 times 3, or 3 times 2 is 6. But notice that 2 is in the hundreds place. 2 hundreds. The 3 is in the tens place. And I multiply 3 tens times 2 hundreds. I multiply the digit times the digit. 3 times 2 is 6. But I also multiply the place value times the place value. And tens times hundreds is thousands. So the 6 must go in the thousands place. Not because we did it by rote, Because we understand when we multiply, and this is true for fractions and decimals, and any time we multiply digit times digit and place value times place value. That is how we multiply. Now, most of you, like I said, I'm assuming know how to multiply, but I'm going to show you a new method, an alternate method of multiplication. Now, if you like your own method, the old-fashioned way, that's fine. But I think this method, called the lattice multiplication method, is really good. And the reason it's good is because it involves no carrying or renaming when you're multiplying. It's excellent if you have no calculator because there's no limit to the size problem you can do. And of course, it's very useful in multiplying multi-digit, as 2, 3, 4-digit numbers. So let's go to the whiteboard and see how to set up this thing called a lattice. And basically, a lattice is just a rectangle that allows us to multiply, and I believe is a much more efficient way of multiplication. Okay? Basically, what we're going to do is we are going to first make a rectangle. And since we're multiplying a 2-digit number by a 3-digit number, we'll divide the rectangle into 3 columns for the 3-digit number and into 2 rows for the 2-digit number. And then we'll connect each of the corners in the smaller rectangles to its opposite. Now, it's very important to go through. In case you need to make a little curvy, that's okay. It needs to be straight, but it must go from corner to corner to corner and out the bottom, as we'll see when we actually do this. So that is how we would multiply a 2-digit times a 3-digit. That is the lattice that will allow us to do this. And in the first visual, we see that we're going to multiply the same problem we just started with, 38 times 247. And we put in the numbers, and then the next visual shows us actually drawing the diagonal lines that will help us to do our adding when we finish multiplication. So we're going to multiply 3 times 7. And the wonderful thing about lattice multiplication is there's no order that you must multiply in, because each of the multiplication parts is independent. And if we do 3 times 7, we get 21. And notice, by splitting each box into 2 parts with that diagonal line, we can write the 2 and the 1, 21. We skipped over to 3 times 2. That was the problem we looked at before. Where does that 6 go? Notice there's a 6 there. Notice the left part of that box is blank. If you want to put a 0 in, that's fine. My wife says that every little place should be filled up. So obviously, when your answer is a 1-digit number, you would put a 0 in that tens place box, if you would. The next visual shows the completion of the multiplication. 3 times 4 is 12. 8 times 7 is 56. 8 times 4 is 32. And 8 times 2 is 16. Then we add, and that's where the diagonals come in. We add along the diagonals. They represent the place values. Okay? So basically, in the ones place, we have a 6. In the tens place, we have a 1, a 5, and a 2. Well, 1 plus 5 plus 2 equals 8. In the hundreds place, 2 plus 2 plus 3, that's 7, plus 6 is 13. We write down a 3, and we carry the 1 over to the thousands place. 1 plus 6 plus 1 plus 1 is 9. And we have our answer. And the next visual shows us that indeed 38 times 247 is exactly 9,386. Now, let's do a few more at the whiteboard. In fact, I think what I'd like to do is start off with a simpler problem and have you try to do it, and then come on back and I'll do it and make sure if you got it right or not. This is going to be a 2-digit by 2-digit problem. So we'll go ahead and set up for a 2-digit by 2-digit lattice. Connect the corners. And again, it's really important. It's not important that the lines are straight. If your hands are shaky, that's okay. And we're going to do 53 times 72. Now, something I should really do here is an estimation.